if you go to page 1 in your packet, okay, what we're going to talk about today is how do we organize data in line plots and stem leaf plots. So I think it's going to be pretty quick and simple. It shouldn't be that hard, okay? And then I'll give you plenty of work time in class to hopefully get most of your homework done in class, okay? So, line plots. A line plot is just a number line to show how often a value occurs in the data set, okay? It's super important we know how to organize data. If you're reading the newspaper or a magazine or anything that has some data in it, they're not just going to give you a list of data. Why not? What would you do if you just see a whole bunch of numbers in a list? I know what I would do. What would you do? Samantha? Not pay attention. How many of you would just skip that part? Right? Now, if they put the data in a table or on a line plot or on a stem and leaf plot, you're a little more likely to look at it because it's at least organized. Okay? So we have to know how to organize it and then maybe how to read it. Okay, so organizing data in line plots. When we're making a line plot, what we need is a number line. And when I look at this data, it's all about student test scores. And the lowest score was 50. Oops, not very good, right? The highest score was 100. And it looks like they all are like 50, 55, 60, 65, that type of thing. So I made a number line going from 50 to 100, counting by fives, okay? Now, all we're going to do is take our data and put X's above every line. Okay, now when you make your X's, you need to make them all the same size. We don't want some X's really big and some small. We want them all about the same size, very neat. Okay, so we're going to start here and go 100, and you're just going to put an X above 100. 60, and put an X above 60. 90, 50. And just keep going. Finishing it up. Awesome. Okay, so when you're done, that line plot should look something like that. Okay, you should have 1x above the 50, 2 above the 60, 1 above the 65, 2 above the 75, 3 above the 80, 1 above the 85, 2 above the 90, 1 above the 95, and 3 above the 100. Okay, now why might it be helpful to write the data this way? What's helpful about that? Is it easy to tell what the lowest score was? Yeah, the lowest score was what? 50. Is it easy to tell the highest score? The highest score was 100. It is way easier from a line plot to tell that information than trying to pick it out of just a mess of data. Okay? I can also tell, do you think people did pretty well on this test? I think so. Overall, the majority of people got 75 or better. And yes, there was a couple low scores. But most people passed. Only one person failed. Okay, so we can tell how kind of the trend of the data and how people did. Can you tell what score was gotten the most? Are you looking at that? What score did people get the most? 80 and 100. They both were gotten 3 times. Okay. Questions on that line plot? All right, let's look at the next one. So this one shows the number of feet of snow each season. Okay, this time I gave you a number line, but it's not numbered. So we have to number it. Any ideas of how I should number that number line? Tyler?
1, 2, 3, 4, 5, 6, 7.
Yeah. When I look at this, I see a 1 right away, so I know I have to start at 1, and I should probably just count by ones. So 1, 2, 3, all the way up to 11. Okay, so you have to make sure that you number the number line. And then we're going to place the data on the number line. So I'm going to just start at the top and put an X above the 4, an X above the 1. And just keep going. So when you're done, hopefully yours looks just like mine. Okay, and I do try to go one at a time so that you don't miss any pieces of data. What's the highest amount of feet of snow that they got? 11, right? How many times did that happen? How many times did they get 11 feet of snow? Caleb, 3. I could say, how many times did they get at least 9 feet of snow? Really? 9. And you guys are able to answer those questions way quicker when it's organized on a line plot. If I just gave you this table and said how many times did they get at least 9, it would take you a little longer because you have to actually go through and count them. Here, it's easy to just look at. Okay. All right, questions on line plots. You'll have to do a couple of those on your homework. Then we're going to talk about stem and leaf plots. We kind of talked about this just briefly before MCA testing. Did you guys see any stem and leaf plots on MCA testing? There's none? Okay. So a stem and leaf plot is just another graph used to organize data and to compare frequencies. What does frequency mean? Do you know what this word means? How many times it happens. So frequency means how often. Okay, how many times it happens or how often it occurs. Okay, so a stem and leaf plot, we have the stem is the first digit, the leaf is the last digit, and we see that 2 line 5, it means 25. Okay, flip the page in your notes packet. So you are going to have a couple problems on your homework that asks you just to list the data values. Okay, and it'll always give you a key. 1 line 2 means 12. So can you tell me the data values in that first line? Perfect.
12 and 15.
Yeah. The 1 goes with the 2 to make it 12, and the 1 goes with the 15, with the 5 to make it 15. Okay, what are the data values in the second line? Brinley. 40, 41, and 41. And then finally 52, 57, and 59. Okay, now this one doesn't tell us what the data is about. Maybe it's ages of people at a family gathering. I don't know. If somebody 12 years old all the way up to somebody who's 59 years old. Okay, questions there? Okay, so then we're going to create a stem and leaf plot. When we create a stem and leaf plot, we have to have our stems and our leaves. Okay, and our stems need to start with the very lowest number. Okay, what's the lowest number in that set of data? Tyler? 12. All the way up to the highest number, and the highest number, I believe, is 47. So what do you think our stems should be? The stems are always the first digit. 1. And what else? 1, 2, 3, and 4. Okay? So we need to go from the lowest number is a number in the tens. Then we have the 20s, the 30s, and the 40s. Okay, so that first number, that stem, is the first number in the digits. Okay, then we're going to go to the leaves. And they have to go in order from least to greatest. So I see I have a 14, a 12, an 18, and a 14. Okay, I don't put the 1 because the 1 is already there. But then I need the 2, 4, 4, and 8. You don't put any commas between them. You just write them next to each other. Okay. Then we do the next column, which is the 20s. So I have 23, a 24. I only have 2. So what number should I put as leaves? 3 and 4. Okay, and they should line up with the leaves above them. Everything should be nice and neat and organized and lined up. Okay, then we're going to go to the 30s. We have a 32, a 36, and a 33. So what number should I put behind the 3, Brinley? 2, 3, and 6. They have to go in order from least to greatest. And then last but not least, the 40s. We have a 47 and a 42, so it should go 2, 7. Now I always want to check that I didn't miss anything. Okay, there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. So how many leaves should I have? I should have 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and I know I didn't miss anything. The last thing we need is a key. You always have to write a key so somebody knows how to read it. Okay, it does not matter which piece of data you choose. I'm going to choose this one, the 3 and the 2. Okay, so I'm going to put 3, line 2, equals what? What does that mean, Brooklyn? 32. So that if somebody saw my center leaf plot, they could figure out how to read it. Savannah.
When you're creating one and let's say like there's no 30s, you still write 3 and you still
Yep. So her question is, if there was nothing in the 30s, you could do one of two things. You could put a 3 there and then don't write anything behind it, or you can just leave the 3 off altogether. Because when I go back to this one, notice there was nothing in the 20s or 30s, and they just didn't put the 2 or the 3 there. But they could have put a 2 and a 3 and just put nothing behind it. Does that make sense? Okay. Any other questions there? Okay, so let's look at another one. Here it says, use the given data to make, not a back-to-back, just a stem and leaf plot of the data of U.S. representatives for selected states in 1950. Okay, so we have our stem and leaves. What should my stems be? What should the stems be, Tyler? 1, 2, 3, and 4. Okay. What should be the leaves behind the 1? Brinley. 4 and 8. We have a 14 and an 18. Okay, how about behind the 2? Tyler? 5. Behind the 3? Brooklyn? 1. And then behind the 4? Kimberly? 3. Am I done? No, what else do I need yet? A key. So we do have to write a key. And I'm just going to go to line 5. You could pick any number, it doesn't matter, equals 25. Questions there? Okay, last one. This one is voting statistics, and so it says their age and how many million people voted. So we want to make a stem and leaf plot of the number of people that voted. So we have our stem and our leaves. What do our stems start at this time? Brooklyn, what do you think?
Would it be 0?
Yeah, it would be 0. So here's the tricky part. There's an 8 here. All of them are 2-digit numbers except for that one. And how do we make the number 8 a 2-digit number? We have to put a 0 in front of it. Okay, so in order to make that a 2-digit number, we have to put a 0 there. So our stems are 0, 1, and 2. Behind the 0, we just have the 8. So I've used that piece of data. Behind the 1, we have 10, 12, 16, and 16. So we need a 0, a 2, a 6, and a 6. And then behind the 2, a 3, and a 4. There was 1, 2, 3, 4, 5, 6, 7 pieces of data. 1, 2, 3, 4, 5, 6, 7. So I have 7 leaves, so I know I've got everything. And then I need a key. So 1 line 0 equals 10. Okay? Questions there?